In today's episode of The Garage, we'll present part one in our special two-part series on cloud computing for automotive with our special guest from AWS, Stefano Marzani. In today's part one episode, we'll talk about data and compute in the cloud. Let's go. On today's episode in The Garage, I'm so excited to welcome our special guest from AWS, my good friend, Stefano Marzani. Stefano, welcome to The Garage.
Hi, John. Thank you so much. It's such a special invite. After 3 years working together, really a special occasion, right? To think about our passion, talk about them, and share our experiences. So thank you so much for inviting me.
We're pleased to have you here. And we were talking about our common interests. And I think I've got at least 4 really great common interests we have. First, beginning with coffee. We love coffee and we're very serious about our coffee here at
I noticed that, right? So it's one of the best coffee I had here in the Bay Area. So good start.
Thank you so much. The second thing that we're mutually passionate about is food, especially Italian food. And as anyone who talks to you can tell, you're from Italy. You're from Bologna originally.
Correct. Bologna area.
What interests me about Italian food is not only that it's great in general, but that all the different regions of Italy have such different food.
Yeah, absolutely.
So I thought I'd love you to tell us about what's the specialty of the region you're from, and tell us the name of the region where Bologna is in.
Yeah, region is already extending the concept because, in Italy, provinces are really the place where you have different food. So I'm originally from the province of Reggio Emilia, and if you move 15 kilometers east or 15 kilometers west, people call the same food with different names. So you can understand how we care about it. But most of the food that you hear here around, like prosciutto, lasagna, that kind of stuff, comes from that region. So literally, Forbes selected it the best region in the world for food a few years ago, but so somebody else saying that, so not just us.
That's fantastic. I'm going to have to make a trip to see that, especially. I've been to Italy lots and lots of times.
You'll be my guest.
That'd be great. And you say there's a fantastic restaurant in the Bay Area that has that type of food.
Yeah, there are several Italian foods, but really specific from the region, it's difficult to find. Okay. So not here in the Bay Area, still looking for it.
We were chatting before the episode also that we have a mutual friend. My grad school office mate is now a professor at the University of Bologna.
Oh, really?
Luca Benini. Luca is a good friend of mine. He's from Ferrara originally, which is also in that province. So, and I understand he's your friend as well.
Yeah, I met with him many years ago. But definitely at the beginning of my career, we started to talk about some electronic stuff, as you can imagine, at that time. So I met with him, I think it's more 20 years ago or something.
That's fantastic. So Luca, if you're watching the show, hats off to you. The third thing we have in common is we both love video and podcasting.
Yeah.
You're a host of your own show from AWS, which is incredibly impressive. And so we're actually so honored to have you as a guest here on our show. Just mention quickly your show and the kind of things you cover, and we'll put a link to the show in on the video.
That's surely appreciated. It's called All Things Automotive. And we are about to start filming the 3rd season of it. First one, unfortunately, was remote during COVID. Yeah. And then we got a season out that was in studio. It was absolutely a great experience. First time for me doing something like that. I was always joking with my colleagues. It's kind of a side job, right? Because I'm a technical guy. I work on real technical stuff. So doing, videos with such level of production, high quality, it's been a special occasion for me and a huge learning. It's a lovely experience.
If you've not seen the show, it's incredible. So you won't look like an amateur. You see it, I promise you. You look like a professional. We're so glad to have you. And really the fourth thing, and really which brings us to the topic of today's episode, is the cloud and automotive.
Yes.
And you're so passionate about that, and you have such a unique role at AWS. I'd love you to tell us about your role and what's your responsibility at AWS.
Of course. So I'm the worldwide tech leader for software-defined vehicles at AWS. So, software-defined vehicle is this new macro trend in the automotive industry that is really transforming the product. We will talk about that later, I hope. But my role is really a tech strategy role. So trying to understand from customer what they need, and talk internally, bring that internally, talk with our services team, talk with our industry products team, and together find the best solutions for our customers. So from the technical perspective. Then I have colleagues taking care of the business, of the partnership side, but my role is really focused on finding out right architectures and what the customer really satisfies them from the technical perspective. And I did that. This is the first, I did a year as a tech leader for SDV. Before that, I was for 2 years the tech leader for ADAS AV, right? So really thinking about this domain and doing the same thing, understanding how the technology is evolving, how we can capture technology evolution and transform it in services and products for our customers. And you know it very well, because there where we started our collaboration from that point of view, right?
Absolutely.
And in there, after last year, was really focused on creating SDV architecture for, autonomous driving and ADAS. So we did a good job, because at the end they said, it's pretty good. So maybe you can do that for all the other workers in the car, including HMI, connected, and so on. So yeah, it's such a privilege, I tell you, to work in this context in such a transformative moment for the automotive industry. So I feel blessed in that sense.
That's right. And we're going to talk about all of those topics. I think this is going to be a long and very interesting conversation. I'm so looking forward to it. We just had our friend here, our mutual friend, Robert Day from ARM.
There you go.
He was in the studio just a little while ago recording as well. And I asked him a question about low power in automotive, because when I asked him, I said, many people, I think, don't appreciate the importance of low power in automotive. You say, a car is a big battery. But actually, he pointed out how important low power is. And I'd like to ask you a similar question for the cloud. People may generally understand the cloud and how important it is, but I'm not sure everyone necessarily understands why the cloud could be so important for automotive.
That's can be a very long answer to that, but there are several reasons. But I really like the point that you started with, because low power in terms of cloud means consolidating resources, and we have a huge effort for sustainability. That at the end is something very important for the mobility sector at large, overall. So, and that's really, really important, right? So consolidating these resources in data centers that are energy efficient, carbon neutral, we have a very important and big objective in being carbon neutral. So that is a way to use resources in a very conscious way. Let me put it that way. I like that starting point. But of course, there are technical reasons why the cloud is relevant in this phase. Think about connected vehicles out there. All the vehicles are connected, very well, right? And I hope to hear from Sonatus, right? It's a dialogue. So I'd really like to see what Sonatus is doing for that, for connecting all this vehicle and their experiences. And where are they sending the data? Most of them are sending data in the cloud, because our service, Amazon S3, is very efficient to store this data, have multiple ways to manage data, to store data in classes, depending on the usage or the frequency of usage of the data. It has automations. If you're not using this data too much, maybe this goes in a tier that it takes a little bit to recover the data, but you pay less, right? So you have all this strategy that comes as managed services that make cloud services so appealing for customers, because they don't have to think about it, right? And they can optimize their IT infrastructure and focus on what really matters, that is innovating for their products. And especially in this phase in the automotive, you know it very well. The product is changing radically. So there's no time to waste, right? So, and our managed service, we are helping because we can let the customer focus on what matters for their customers, the people who is buying and experiencing the car, right? So, and S3 is just an example, but that can be applied to compute services, machine learning services, and all our services we offer that have similar logic. We manage service, as we say, we have, and we try to avoid customer, and we absorb the undifferentiated heavy lifting that our customer have, right? Repetitive task, we just automate them where possible, and shift to the cloud. All these processes make the life of our customer easier.
Thank you for that summary. That's so interesting. I was thinking we might discuss the cloud in 5 aspects today. And it seems to me these are the aspects that are relevant to the automotive market, which is first is data. Second is compute specifically. Third is about prototyping, because I think there's a real aspect of prototyping for vehicles.
Yes.
The fourth is analytics and artificial intelligence and machine learning. And finally, the fifth, which we mentioned earlier, is autonomous and ADAS, where I think the cloud can offer some specific advantages. So let's start with data first. Cars and vehicles of all kinds are producing more and more data, especially as they're being connected. So let's talk about some of the ways that the cars produce data and some of the things you see are the most interesting examples of how data can be used in the cloud?
Yeah, so first of all, the quantity of data is just, really a lot. That's what we are observing. So I'd say that the first trend is optimize the collection of data. So talking about data, how we can reduce or optimize, right, this data logistics. We have several services, of course, to collect data from our basic IoT services and services for data logistics, right? Sometimes the data collected, especially by our autonomous driving customers, it's so much that you can just transfer it to the internet. So we have physical devices called Snowball devices, Snowball Edge, that physically, you download this data inside these devices and you ship the device to AWS in order to upload or download it, the way you see it, to the cloud, this data. So data logistic is a thing. So maybe we can discuss that later because it's really a combination of compute and data, if you'd like, right? More and more. So we call it this big loop that you are very familiar with. Interesting data, what I can tell you, a recent trend we see more and more from customers is about videos, right? It's very important to think about how rich a modern car is in terms of sensors. You have not just anymore, like in the past, the collection of CAN data, so the controller area network data, simple data like speed, position, steering wheel data, braking status. But more and more we see rich data coming in. So we have video cameras, several video cameras in a car, LiDARs. We start to see regular car, high volume car adopting LiDARs. That's totally new for the market. We have radars, right, ultrasonic sensors, and so on. So it's, I'd say that the modern trend we see collecting this data, and this will generate a new generation of services. Think about the possibility, for example, to observe through your vehicle's cameras what's going on around the vehicle on your smartphone, right? Services like this are really will change in a way our experience with the vehicle itself. We will see the vehicle more and more as a sensor set, if you will. So rich data and used for these different purposes: security, safety, traffic management, traffic logistics, mobility systems as well. And personally, there's one that I'm very passionate. Everything is ADAS safety related. That's an easy win. And it's a big win because if you look at statistics, still there are a lot of dangerous situations out there that can be mitigated by the use of ADAS now, right? That's data that to me has a special weight, if you ask me.
Absolutely. And we're going to definitely spend some time on ADAS and autonomous later because I think that's a whole area in and of itself.
Yes.
But that's really interesting. You talk about the different kinds of data. Sonatas, we care very much about data. It's one of the areas we focus on. We see that the conventional data gathering approaches tend to be quite rudimentary and fixed.
Yes.
And what you tend to see, we believe, is that there's a need for dynamic adaptation of the kinds of data, whether that's things like vehicle dynamics for things like tuning the vehicle, diagnostics. We're seeing a growing need that as vehicles become more complicated and you're seeing recalls and so on like that, you want to really avoid those problems and by diagnosing them in the field. And we think fine-grained, configurable data capture can be a really important thing. And that's one of the reasons you're such an important partner to us because that data goes to the cloud, it needs to be acted on, and we're going to talk about analytics and other kind of things. But getting the right high quality, trustworthy data to the cloud, I think is important foundation. And you mentioned also rich data as well. We also see that as well. We believe that by marrying together, for example, vehicle dynamics that says, well, there was a harsh steering event with, let's say, camera data or radar data, you might be able to actually do a better job of tuning an algorithm perhaps than if you had any one of those in isolation. And so merging different data streams together can be, I like to say 1 + 1 = 7.
Absolutely. I totally couldn't agree more. And this is very in line, by the way, with our definition of SDV. We started with this, our definition saying, of course, SDV is introducing new functions in the vehicle, software function in the vehicle when the vehicle is out, right? And that's was our definition. And speaking with customer, realized it's a little bit more than that. Right? They say, but we're not just there in the cloud. We have a physical product here. So we want to use the data that is generated by the vehicles to improve the physical aspect of the product, its own components, right? Think about the steering system, a braking system, how we can generate, start to design the next generation power steering of a vehicle if we collect the data from the majority of the vehicles out there, right? So we added this section to our definition of SDV. So it's not just more new functions while the vehicle is out, but taking these insights, right, to design the next generation vehicles in all their dimensions, including the physical ones. And there are plenty of examples of that. So totally agree. It's more and more important. And the dynamic relation between, it's not just saying, okay, sending down a configuration, collect this data. No, maybe there's a special condition we want to detect. If we see that condition, we want to explore a little bit more. And so let's try to have some more data from some other sensor to see if we can understand better the situation. So this kind of logic are top of mind for our customers. And again, not just for design purposes, but if you think about it, it's an optimization of the system.
Right.
So why are collecting all the data and use 10% of that? Maybe we can have more granular ways, more smart ways to collect data. And okay, if you don't see anything weird or particular, just don't record, right? If you see a specific situation, give me the 20 seconds and send it up.
That's right.
Right? So that's why we can have more data, but overall, less data that we are collecting, because more meaningful data, if you will. So not just more data and that's it.
That's right. I kind of call it the needle in the haystack problem, where actually there's, if you think about it, normally everything's working fine, but then there's this specific region when something really interesting happens and you'd love really high resolution data, but you couldn't capture that high resolution data all the time. It'd be overwhelming. That's one of the areas we focus on, for example, is to address that. You mentioned also the being able to make vehicles better. We were talking with an OEM, a car company's product manager, and he was saying, one of the problems we have is once the vehicle leaves our shipment, we don't have fine-grained understanding of how the features are being used. So we design in this feature, and we don't know if anyone ever uses it, and it's very expensive to put in. Maybe we could optimize the cost of the car or spend the resources in another area. And so that's another area where we can optimize both the OEM's cost and the user's experience by giving them the features they care about.
Absolutely.
And so that kind of thing. Another area that we think is really interesting, and you kind of touched on it, is it's not that there's not one need. There might be a diagnostic need, there might be a future product analysis need, there might be some sort of ADAS, and they may coexist at the same time. And today, that's not the way it's typically done. That's one of the capabilities we're trying to build into cars. It's close to our heart. We're a little passionate about that.
Absolutely. No, and I share the same passion, by the way. And totally in line, by the way, we will talk about machine learning and artificial intelligence, but I frequently say to our customer, when I'm talking about automotive nowadays, cars will have multiple intelligences. It's not just one. It's not just I'm going to deploy ADAS, that's it, as a neural network. But think about Alexa, right? An artificial intelligence that is able to interact with you. And you may have driver monitoring. You have, I think, plenty of artificial intelligence working at the same time on different data sourced from different parts of the vehicles for different purposes locally. Some of it needs to be sent out, right? And sent up to the cloud for analysis, analytics, and to understand what's going on. I want to provide you, though, another point of view. I think it's very interesting in that. It's not just OEM. Think about the supply chain of the automotive and the value chain. I personally think that it's not just the vehicle that will be software defined, but the vehicle components will be software defined, right? If you want to really improve a subsystem of the vehicle, you have in a way to transfer this knowledge to the manufacturer of that component. So that really is, kind of reading again this value chain through these data pipelines in a way that needs to flow through the data to the supply chain and the value chain of the automotive. And I think this is interesting because in that way you really produce superior products. We do that, for example, for battery management. That's a very, very classical example, right? In electric vehicles.
Exactly. That's a perfect example we're hearing a lot about. Is you have these components which historically or in existing approaches don't maybe have access to share their data or share analytics, but that really need this kind of algorithmic tuning or algorithmic improvements. And so I think that's something which is a need which is unmet today.
Yeah, absolutely. Totally agree. So that's a very interesting part.
So speaking about data then, could you give us some examples of some customers that are using your services and the different ways they're using it? Absolutely.
So for example, we have a very good customer reference with BMW. They created this connected data lake, and they presented it in one of the episodes of All Things Automotive, so it's online. But even more, there are very technical, deep analysis in one of our previous reInvent conference. It's our annual conference for developers. Their case is so interesting because essentially you can really see the effort they did to aggregate various sources of data in this connected data lake. And then this data lake serves the entire organization in all its part. That's their effort, right? And it's absolutely great because you know that you have this reference and the data is just used and can be used by IT, R&D departments, whoever need it. So I think this is great. This is great if combined with cloud technology, APIs, right? So application program interfaces, clear interfaces, microservices, and that gives the capability for organization to build the application that uses data quickly, right? That's very important objective nowadays.
So a single source of truth and a common framework that people can base on, it's really powerful. And this data lake is an important idea, and we're happy to be part of that and happy to be sending data to that.
Yeah, and I think you're doing absolutely a good job in organizing your data, not just, let's say, in the mechanism you transfer data, right? But in the tools I saw, in the console, in the various interfaces you're proposing customer to work with this data to create automation. So it's really an important aspect, right? So not think just a specific thing, but this organization are a big organization, a complex organization. So agility is implemented really in the capability to offer specific services, right? But the data is the truth. So that needs to be consolidated in a proper way.
Well, that's quite a long discussion about data, and perhaps we could have a whole episode on data, but let's move to the next topic, which is compute.
Sure.
And cloud computing is perhaps very famous. People understand that cloud has incredible compute capabilities. So I'd love if you give us an overview of some of the capabilities you have, and especially those that maybe apply to the automotive
Absolutely.
market.
I'm more than happy to do so because that's one, let's say, big asset that we have in AWS is the variety of compute options. Compute options that, by the way, people can use on demand, right? So that's a very important thing because in automotive, it's not just a consumption that is always stable. No, maybe you have to do a resimulation exercise and that will spike up the consumption of compute resources. But the day after you're done, you have zero consumption. So that's a basic issue that we see with some customers that have their own data centers that they already paid for that, right? While the compute offering that we have is on demand. So you need it, you just pay for it. You don't need it, you don't pay for it. So that's a big part, I think, in being flexible, in being elastic in the usage of resources. So, and that's where variety is very important. We have several instances, as we call them, that is these compute resources, EC2 instances, Amazon EC2 instances, elastic compute, right? So that's the reason of the EC. So, and this is a very important part because you have Intel instances, ARM instances, Xilinx instances, so Xilinx-based FPGA instances, and so on. And if you look at each class of these instances, you have instances that have more memory, more compute power. They have GPUs, or they have special features, more bandwidth in terms of networking, according to adapt to the specific compute need. And this is very important because we discussed about it. You have all this data coming in. What do? You want to have machine learning, for example, training using this data. There you have P instances, for example. And this is accelerated compute specific to train data. In there as well, we have some chips that we developed. It's called Trainium, right? So that is our own produced chip that is able to train these machine learning networks using the data that has been collected. In let's say when you did the training, you wanna exercise the model. So we have Inferentia, that is another own built chip that is specialized in doing this work, right? But again, apart our own offering, it's really important to provide this variety. We have Mac instances, for example, right? So because if you are an Apple developer and you want to really produce this development pipeline at scale, you can use Mac instances and scale them out. So, and we really have solid data about the fact that you really need this granularity when you adopt the compute choice where you have that. For example, again, from re:Invent, Continental explain how adopting the cloud in this resimulation exercise to their catch platform applied to a ADAS case really significantly shortened the time that they were using to train a specific ADAS functionality. So we have more and more data points that support this kind of cloud adoption in terms of compute.
Well, talking of specialized instances, we have to talk about Graviton.
Yes.
Can you tell us a little bit about that?
Yeah, of course we need to, because we started our collaboration, right, working on these ARM technologies. So absolutely, it's our own processor developed by our Annapurna Labs. That is, our specialized business unit, if you will, that is producing all these silicon innovations, including Graviton, Trainium, Inferentia, and so on. And it's an ARM-based chip. It's a CPU. It's 64 ARM cores, ARM v8 in the cloud. And when it's been released, it was the first ARM chip in cloud systems and adopted at scale. And it's very important for several reasons. At the beginning, it was really for power performance, and we discussed how important it is, the sustainability aspect in adopting the right compute options, right? But more and more we discovered that ARM is a technology, is an architecture frequently adopted in vehicles by our customers. So we said, maybe we can do a little bit more with that, right? And maybe we can discuss about that.
Thanks, Stefano. I really appreciate that summary of compute in the cloud. So this concludes part one of our special two-part series with Stefano Marzani from AWS. In today's episode, we talked all about cloud computing for automotive, particularly about data and compute. In part two of our conversation, we'll continue and talk about prototyping with the cloud, data analytics and AI, and finally, ADAS and autonomous driving. We hope you will take a look at part two, which we'll publish soon. Thank you for joining us, and we look forward to seeing you again in another episode of The Garage.